Hi, so I hope everyone's well today. In today's video, we're going to be looking at simultaneous equations and solving them either by elimination, substitution, or graphical observation. Okay, so in the elimination method, we add or subtract our two equations to remove one of the variables. So we want to get rid of either the x or the y so we can solve our equation. In our substitution method, we rearrange one of our equations to get x equals or y equals, and we substitute that in the other equation. And for the graphical method, we draw both lines and see where they intersect. Okay, so the elimination method first. So we have something which looks like this. We want to solve it for x and y. So the first thing we have to do is we have to rearrange it to get the x and y's on the same side. So this one becomes 2y minus 3x equals 4, and this one becomes y minus 2x equals 1. And actually you don't need to write it separately up there, just go straight in and write it here. You then have a little look and see if there's anything you can multiply one of your equations by, so you end up with the same number of either x's or y's in both equations. So I can see if I multiply this bottom equation by 2, it will become 2y minus 4x equals 4, and then you have the same number of y's in both. And when I subtract my two equations, as I'm going to do here, hopefully you can see that the 2y take away 2y equals no y's, and the y's are eliminated from my equation. So let's do the subtraction. 2y minus 2y equals 0. Minus 3x minus 4x gives me x. 4 take away 2 gives me 2. So I've got my x solution. I also need my y solution. Then you just take that x solution and put it in one of the original equations. It doesn't matter which, but this is the easier one. So you have y equals 2 times 2 plus 1, 2 times 2 plus 1. So you'd get y equals 5. So you found the x and y values which will make these two equations work. Okay, now if we want to do the substitution method, or need to do the substitution method, it's normally because you've either got an x squared, xy, or y squared term. Some people do prefer to do this always, and that's also fine. It is best to substitute from the simpler equation to the more complex one. I would suggest it might not even be possible to do it the other way around, so it's a bit of a silly thing to say. And this can be messy, just stay calm. Okay, so here we go. We've got these two equations and we want to solve them simultaneously. So the first thing I'm going to do is take my simpler equation and rewrite it so I get x equals something. So I get x equals 2y plus 5, just adding 2y to both sides. I could rearrange to get y equals, but obviously with this equation it's easier to get x. Then once I've got my x equals, I then just put it into the other equation. So where I see x, I write 2y plus 5. So that gives me this one, 2y plus 5 squared plus 2y equals 11. I'm then going to need to expand this and simplify it a little bit so I can try and solve it. So expanding out this bracket, you get 4y squared, 2 lots of 2y times 5, so that gives you 20y, and 5 squared gives you 25, plus the 2y squared equals 11. So sort it out a bit and you get this. Now hopefully you can see that this, the 6, 20 and 14 all have factors of 2 in them, so you can then divide by 2 to make your life simpler. And please remember to do that before you start factorizing into 2 brackets, because it's just much easier. So this factorizes into these 2 brackets. Now some people find that quite difficult, and if you find that difficult you can use the quadratic formula. Don't worry about that, just do it. I have got a video on factorizing into 2 brackets where the coefficient of the x squared term isn't 1, so you can watch that and see if that can help you. So hopefully you can see that this does indeed give you that. So you get the 3y squared, which you want, and you have 3y times 1 gives me 3y, and 7y, 7 times y gives me 7y, and 3y plus 7y gives you the 10y, and then you have 7 times 1 gives you the 7. So these two things are equal. And then we want to solve them. So what we say is we look at this and say if all of this equals 0, then either this bracket equals 0 or this bracket equals 0. So this one's the easiest one to see. When would that equal 0? That equals 0 when y equals -1. This one's slightly harder. When would this bracket equal 0? So you could write 3y plus 7 equals 0. Take 7 from both sides and divide by 3, and you see that that equals 0 when y equals -7/3. So once you've got these, you then substitute them back. I'll do the easier one into here, and then you can get your x value. So x equals 2 times -1 plus 5. So that would give me x equals 3. And then this one, I have x equals 2 times -7/3 plus 5, and you can just check that that gives you x equals 1/3. And so we've solved it, and this time we've got 2 solutions, and that's because you've got a sort of squared terms here, so you'd expect more than one solution. Okay, and then finally the graphical method. So if we have 2 equations and we graphically want to see the solution, we just have to plot our lines and then see where they cross. So for this one, when you've got linear equations, you just need to find 2 points and then draw a straight line between them. So I would choose the point when x equals 0. I'd get y equals 1. And then I could just put whatever I want, x equals 1, so 2 times 1 plus 1 would give me 3, so I'll get a second point here at x equals 1, y equals 3. This one, put when x equals 0, 2y equals 4, so y equals, they're not very accurately drawn these, but never mind, y equals 2, and then I might choose 2, x equals 2, so 3 times 2 is 6 plus 4 is 10, divided by 2 is 5, and so when x equals 2, y equals 5. And then you can see from this, you can read off the solution. And actually it's quite interesting because I've drawn these quite badly. You can see that if you don't draw them well, you're not going to get the really good answer. So the answer here should be 5. And actually, I would say that looks more like there. So it's important if you use a graphical method to draw them more accurately than I have done here. Okay, I hope that's helpful. Have a good day.